Talking about transformations of quadratic functions in vertex form, and we want to describe transformations of quadratic functions and write transformations of quadratic functions. So for quadratic function, the parent function is always y equals x squared. There's some variations that we can have for that, and one of those is vertex form of a quadratic function. So right here, we still have the x squared term. We just have it with a little bit extra. So x is still squared, which makes it the quadratic function. But then inside the parentheses with the x, we have a minus h. Outside the parentheses, we have a plus k. And in front, we still have that a value. And that a value is going to act the same way that it has for the standard form and also for factored form. The reason that this is called vertex form is because the hk is the vertex of the parabola. So we can tell right from the equation exactly where our vertex is. We don't have to calculate it. X equals h. So this value right here is also the axis of symmetry. The h value shifts the graph along the x-axis to the right and to the left. So if h is less than 0, it shifts the graph to the left. If h is greater than 0, it shifts it to the right. Now this is backwards from the way it looks in the equation. So h looks backwards because the negative sign in front of the h in the original equation. So right here, if I substitute a negative value in here, x minus negative 1, in the written equation, it would look like x plus 1 because there's two negatives in a row. So the h is backwards. The k is straightforward. The k shifts the graph up and down. So if k is less than 0, shifts the graph down. If k is greater than 0, shifts the graph up. Let's take a look at a couple examples. So here we have the black function f of x equals x squared. And that's this function right here. That's the parent function. So we can see that the vertex of this function goes through at 0, 0. Now, if we take a look at h of x, which is the green function, the x is all by itself, so there's no shift left or right. However, there is a shift down, so the vertex goes down 3. 1, 2, 3. There's the vertex right there, and we can see that outside of that function, it shifts it down. Now let's take a look at left and right. We have g of x equals x minus 2 squared. So this is minus 2. So normally we're thinking move to the left, but because it's the h portion is backwards, we're going to move it to the right too. So here's the parent function, 1, 2 to the right, and there it is right there, and then we still have that same parabola. Same thing for j of x, x plus 4 squared. Plus 4, remember we got to think backwards, so we're really going minus 4. So 1, 2, 3, 4. There's the vertex. One more thing to talk about, the a value here. So the a value is a scale factor for the parabola. It vertically stretches and vertically shrinks. As the a gets larger, the graph gets narrower or rises faster. A cannot be equal to 0. If this a value is equal to 0, this whole term drops out and we're just left with a horizontal line, a vertical line where horizontal line where y is equal to k. If the a value is negative, a is less than 0, it's concave down. If the a value is greater than 0 or positive, it's concave up. So here we have, if the graph is between 0, the absolute value of a is between 0 and 1, it's going to be a vertical stretch or vertical shrink. So it's going to get wider. If the absolute value of a is equal to 1, it's going to just be the same as the parent function. And if the a value is greater than 1, it's going to be a vertical stretch. Here we have a couple examples. So we still have that parent function. There's that black parent function right there. That's the k of x. Then we have this green function, m of x is equal to 1/2 x squared. Here's the a value, which is 1/2. So this is where we have a vertical shrink. So our parent function normally looks like that. Now it's like compressed closer to the x-axis. As we can see, it gets wider a little bit faster. And then we have the red function n of x right here. We can see that because it has the a value of 2, it's going to get vertical a lot faster than the parent function did. And then the last example, not only do we have a vertical stretch, so basically we're taking this red function here, but also we have that negative value, so it takes that red function and flips it over the x-axis, and so then it points down like that. So we can take a look at a couple examples just to see. Here we have the parent function, and we can take a look at a point. So here's 0, 0, that's the vertex. Another good point to look at right here, we can keep in mind, is the point 2, 4. So if we go over 2, up 4, that's the point of the parent function. Same thing here. We graphed this one already, or we looked at this one. We have the point 0, -3 from that green function there, where the k value was -3. So the parent function shifted down 3. Now, if we go over 2, 1, 2, up 4, 1, 2, 3, 4, we still have the point 2, 1. So previously it was 2, 4, and now it's 2, 1. So basically that point just shifted down 3. The whole graph just shifts down 3. We can turn off the green function. So this one says shift to the right 2. So 0, 0 becomes 2, 0. You can see it right there. And then also the point that was 2, 4 now becomes 4, 4, 4. So basically it just shifted to the right 2. And then we did this one also. So the vertex shifts to the left. The point 4, 2 also shifts to the left 4 points. If we look at y equals x squared, we have that one graphed already. So that one's overlapping there. And let's change the color. We can change this one to orange. Just see what happens if we put a negative on there. So that negative a value flips the graph over. If we put a 2 there, we can see that the graph gets really narrow really quickly. So if we go over 1, so for the orange function, so our point 1, 2, so we go over 1, up 2. For the parent function, that original point, let me click on it. For that parent function, 1, 1, so we go over 1, up 1. So that 2 value, we're actually multiplying by the y value. And then we can take a look at, we can do one more. Let's do 1/2. Okay, and that was a negative 1/2, so that flipped it down because of the negative value. If we get rid of the negative, now instead of going over 1, up 1, we're going to go over 1, up only 1/2. So that's getting pulled closer to the x-axis, or it's flattening out. So anytime we have a fraction here, we're going to think about getting really wider than the parent function, or anytime that we have a number bigger than 1, it's going to be inside or more narrow than the parent function.